Hello, dear students. We missed you today. Today we took the lesson Low Flavors, Lesson 2, Unit 1. Before we start, I can remind you with that we said before 1 to 3 ORF. 1, 2, 3 ORF. What did that mean? When we are studying the first and second and third class level, we know that the fulcrum in the middle in the first class, resistance in the middle in the second class, force in the middle in the third class. Okay, now after revising that part, let's move to our new lesson. First one, or first slide, we have to know that the law of levers is the effort force multiplying by its arm equal to the resistance force multiplying with its arm. You should know that both sides should be equal. Your effort multiplying the arm should be equal to the resistance that you are lifting or carrying. Now, let me show it to you on the drawing. Here is the force, which is the resistance force, and here is the effort force, and in between them, the fulcrum, which is in the middle. So this case, we can call it first class lever because the fulcrum is in the middle. Where is the resistance arm and the effort arm? The resistance arm, as you see in our definition, let's start by the effort arm, take the distance between the effort force, and here is the fulcrum. This distance, it's a length, it's an arm. So the distance, we are calling it effort arm. What about the resistance arm? To the distance between resistance force and the fulcrum. So this is, we are calling it resistance arm. Focus, because according to the length of each one of them, we will say if this lever is good, we can get benefit of it, or it's just like we can use it for something else. Let's start. First of all, the force arm and the resistance arm is measured in centimeter and meter. So here, when we are talking about the length, we can use the centimeter or meter according to the question. We can write the result. The effort force and the resistance force, when we are talking about force, so measured in what is the unit we are using it for, the force is Newton, like the weight. Next. When the effort arm longer than the resistance arm, lever conserve effort. In which class we can find this? Some of class 1 and all of the second class. Class 1 or the first class, some of them can save effort and some of them no. According to what? According to the place of the fulcrum. If the place of the fulcrum is in the middle, so both arms are equal, so this one will not save effort. Focus. Let's start by this example first. Effort arm longer than resistance arm. Let me check. Where is the effort arm? This part, the right side. Where is the resistance arm? This way, left side. Which one is longer? The effort arm, longer than resistance arm. In that case, it looks like the crowbar, like the one this man is holding. Look, this is the fulcrum. This is the resistance arm. I'm pointing to the picture, and this is the effort arm. If this one is applied, so this is very good lever and it can help me for carrying this heavy box. Okay, let me check up. This is second class lever. We can find that the load in the middle. If we are pressing by the effort and the other side, and here's the fulcrum on the right side. Look, let me check. Where's the effort arm? Here, this is this one, this big one, which is the long one. Where is the resistance arm? The small one. So again, when the effort arm longer than the resistance arm, this one can conserve or save effort. But the same way, look, this man, he is doing a very small effort for carrying or lifting 1 ton. Look for the resistance arm. Where is it? Here, between the 1 ton, which is the resistance force, and the fulcrum. And where is the effort arm? Between the fulcrum and the hands of the man. This is the effort arm. So which one is longer? Effort arm longer than the resistance arm. So this lever is very good and very nice and can save effort. Look for this one. This is second class lever because the resistance is in the middle. Where is the effort arm? From the fulcrum to the effort force. So very long. Where is the resistance arm? Very short. This one. From the fulcrum to the resistance. This is the resistance arm, which is small. So all of those levers can save effort. Let me check another one. If the effort arm and the resistance arm are equal, like this one, so you are doing the same effort for carrying this load or this resistance. So this lever does not conserve effort. Why we are using it? We are using it as a game, as we can say a tool for carrying something like this pot or something else. But here it doesn't conserve effort. You are not doing a small effort for carrying big objects. You are not doing that. You are doing the same effort for carrying the same object if you are putting it in a bag. Okay, so this lever is not useful all of the time, but it has another benefits. We will say it at the end. Check this one. When the effort arm shorter than the resistance arm. Now let me check with you first. Where the resistance arm? We said that the resistance is this boot that this man trying to catch it with the fishing hook. So let me check. From the fulcrum to the resistance. So this is the resistance arm, which is very long. Where's the effort arm? The other hand. This is the fulcrum, and this is the other hand in the middle. So we can call this part the effort arm. So which one is longer? For sure, the resistance arm. In that case, look for the other drawing. Here is the resistance arm longer than the effort arm. For that reason, we can say that lever does not conserve effort in that class, which is the third class. Okay, so why we are creating or inventing third class, like the ice holder or the tweezers or the cool holder or the cake holder. Why we are doing all of this? We are creating them. What about the bat, the hockey bat, or the broom, manual broom? And here is also the hockey, the fishing hook. All of those, they are examples of the third class. Why we are creating them? Avoiding danger, avoiding the increase the distance, like the hockey bat, we are hitting the ball for increasing the speed, increase the distance regarding the manual broom. Here is increasing the distance also for the fishing hook. ممكن Here we have like a comparison or telling you different places of the fulcrum for the first class lever. We said in the first class lever, what should be in the middle? Fulcrum. So here's fulcrum, fulcrum, fulcrum. All of them, they are in the middle. So what is the difference? The difference that the fulcrum here near to the resistance. So we have a very small resistance arm. But here, the fulcrum in the middle, exactly. So both arms are equal, while the last one, the fulcrum near to the force. So we can find that the force arm is shorter than the resistance arm. In that case, try to remember the basket bag that we were playing with it last week. When we were putting the resistance near to our shoulder, like this one, the first one, we were doing very small effort for carrying this basket bag. While, as I told Saif and Bibu and many of the students were carrying it I told them to increase the length of the resistance arm, to put it at the back, and keep a short distance between the stick in front of you and your shoulder. And that one, the third one. And you can find that, oh, it's very heavy basket bag by this way, because we made a very long resistance arm and very short effort arm. So which one we can say it's we can get benefit, or it we can save effort? So in the first class level, we can find three cases. The first case only which can save effort or has a mechanical benefit, while the other two, when the two arms are equal, or when the effort arm is shorter than the resistance arm, so we are doing big effort for carrying this resistance. For that reason, both of them, the last two, or the middle and with the one on the right side, both of them, they are do not save effort. Take care. A very important note: first class lever is the most popular one. Next, second class lever. In this type of levers, always save effort. So when he's asking you which class always saving effort, so it should be the second class. So, okay, can you tell me why? Look for the resistance arm. It's always shorter than effort arm. And we said when the resistance arm shorter than the effort arm, it will save effort, and it has a mechanical benefit. So let me read it. Because the effort arm is always longer than the resistance arm, so the effort force is always smaller than the resistance. Next, third class lever. This type of levers do not conserve effort because no mechanical benefit. The arm the resistance arm is always longer than the force arm. The effort force is always longer than the resistance. So here you are doing very big effort for raising or carrying any stuff. For that reason, it doesn't save effort. Okay, so why we are inventing the third class lever like the tweezers? We said when we are carrying the forceps or inventing the forceps for doing small or carrying small objects, like the one who is working in the electronics, he want to carry small parts, so he can use the tweezers. You cannot hold it with your fingers, so it has another benefit. It's not important only to save effort. It should only have another benefits, like the importance of lever that we said in the class last week. What about the cool holder? Can you touch the cool with your fingers? No, you cannot. So it's very important to use the cool holder, which is one of the third class levers example. Okay, now here the last slide, comparison between all of them. Some of them save effort and but others do not. This is the first class lever. Second, always save effort. Third, always do not save effort. What about here is some of them have, I'm talking about the first class, some of them have a mechanical benefit, but the others have other mechanical benefits like increasing speed, increasing distance, avoid dangers, and accuracy in performance. And here is on the other side, all of them, they have mechanical benefits as saving efforts. And here is they are used to increase speed, also increase distance, and they are used to avoid dangerous accuracy in performance. Now it's time to solve the classwork. I printed them um, and distributed in the class, and you can find it the same like this. We can start by typing together what is the answer for this question. First of all, let me read it with you. When a lever is balanced, it was found that there is a force 3 newtons at the distance. When he is telling you force, he means the effort force. 3 newtons at a distance 4 centimeters from the fulcrum. So let me write the rule first. What is the rule? The rule is effort, force, You should write it like this. Multiply its arm equal resistance force multiply its arm, and then you have to write the numbers. We said that the effort force equal 3. Multiply the length, which is 4 centimeters, equal the resistance force. Sorry, here we have to write it here. The resistance force, the one calculate the resistance. If the resistance distance is 2 centimeters, so here with the resistance force, the one that we don't know. This is the question mark, the unknown. Multiply the resistance arm, which is 2 centimeters. So what shall we do now? This is like cross multiplication. You took it in the math. We are going to write resistance force equal 3 times 4, 12, divide 2 equal 6. 6 what? We are measuring resistance force, so we have to write Newton. 6 Newton. This is the answer. Next, I'm going to read with you the second question. In an experiment, the following results were recorded. Force equal 10, load, which means the resistance, equal 20 newtons, resistance arm 4, so find the force arm. You have to copy the same rule and write it down when you are answering. And then write down effort force, here we have 10. Multiply what? Its arm, which is, we don't know it, question mark, equal the resistance force, which is 20. Multiply how many? What this 4 centimeters. So now let's write what is the unknown here? The arm of, or the effort force arm. Let me write it. Effort force arm equal what? 20 times 4, 80. Divide 10 equal, just 8. 8 what? Effort force arm, so we are measuring the arm, the length, so we have to write centimeter. Okay, this is the answer of the second question. I will send you the soft copy of the booklet to find out the classwork and the problems, and you can solve it alone at home. Okay, let me answer with you the last one. In an experiment, the following results were recorded. So first of all, what we're gonna do, we have to write the rule. Do not forget. Please write the rule. And then I will make like this, an arrow to complete my answer. He gave me the force, the effort force, which is 500. So I'm going to write 500. Multiply resistance force, the other side. What about the arm force? 20 centimeters. So I'm going to write multiply 20 equal resistance force 200. Multiply, for sure, I don't know the resistance arm, so this is the unknown. So the resistance arm will be equal 500 multiply 20 equal 10,000. Divide 200. The two zeros will be removed together, so 10 divided 2, right, equal 5. We said 10,000, so we have a missing zero, as the two zeros will go together. 100 divided 2 equal 50. 50 what? We are measuring the resistance, so mm, the resistance arm, so 50 centimeters, not Newton. Okay, now we have finished solving the problems. I think that the other page you will find it is a give reason. If you found any problem, you can ask me and send me a message. I'm waiting for you. Tomorrow we are going to complete the classwork online. Okay? See you. Bye.